Hi guys, welcome to my study compass. In this video, I'll be walking you through the past paper, Math P2, Variant 2, May-June 2019. Let's get started. Write down a prime number between 50 and 60. One of the prime numbers between 50 and 60 is 53. The other prime number in this range is 59. Use your calculator to work out square root of 1 minus sine 33 degrees all squared. Ensure your calculator is in degree mode. When we type this into the calculator, we get 0.839 rounded to 3 significant figures. Write the recurring decimal 0.7 as a fraction. Let's call the recurring decimal x. When we multiply x by 10, we get 7.777. When we subtract x from 10x, we get 9x equals 7. When we divide both sides by 9, we have x equals 7 over 9. Complete each statement. A quadrilateral with only one pair of parallel sides is called a trapezium is a quadrilateral with only one pair of parallel sides. An angle greater than 90 degrees but less than 180 degrees is called. Angles that are greater than 90 degrees and less than 180 degrees are obtuse angles. The distance between Prague and Vienna is 254 kilometers. The local time in Prague is the same as the local time in Vienna. A train leaves Prague at 15:20 and arrives in Vienna at 19:50 the same day. Calculate the average speed of the train. Average speed equals the distance traveled divided by the time taken. To find the time duration, we subtract the arrival time from the departure time. The local time in both places are the same, so we do not need to worry about any time conversions. So we have 1950 minus 1520. Under the minutes column, 50 minus 20 is 30, and in the hour column, 19 minus 15 is 4. And so we know the time duration is 4 hours, 30 minutes. To convert 30 minutes to hours, we divide 30 by 60. We've already been given the distance as 254 kilometers. When we type this into the calculator, we get 56.4 kilometers per hour, rounded to 3 significant figures. Solve the equation. 9f plus 11 equals 3f plus 23. When we group like terms, this is what we have. 9f minus 3f is 6f and 23 minus 11 is 12. When we divide both sides by 6, we get f equals 2. Calculate the area of this triangle. For this triangle, we know its base and perpendicular height, so we can use this formula to find its area. The base B is 8.4 centimeters and the perpendicular height h is 3.5 centimeters. When we type this into the calculator, we get 14.7 centimeters squared. Write 0.047883 correct to 2 significant figures. The second significant number here is 7. The number after 7, which is 8, is greater than 5. And so we add 1 to 7, giving us 8, and ignore all the numbers after 7. This leaves us with 0.048. Write 0.00527 in standard form. To write this number in standard form, we move the decimal point to a position after the first non-zero digit, which gives us 5.27. Since we moved the decimal point 3 times to the right, we multiply 5.27 by 10 raised to the power -3. Find the highest common factor of 90 and 48. To get the highest common factor, we first write 90 and 48 as a product of their prime factors. Now we need to note the common elements in both of their prime factors, and in this case there is only 1, 2 and 1, 3 common to both of them. So to get the HCF, we multiply 2 and 3. This gives us 6. On a map with scale 1:25,000, the area of a lake is 33.6 square centimeters. Calculate the actual area of the lake, given your answer in square kilometers. In our setup, we note that the scale ratio is 1:25,000. Since we are dealing with area in this case, we square the ratio. We know the area of the lake on the map is 33.6 centimeters squared, and we want to find the actual area of the lake. This is what we are calling y. When we cross multiply and make y the subject, this is what we get. To convert centimeters squared to kilometers squared, we multiply 33.6 by 10 raised to the power -10. When we type this into the calculator, we get 2.1 kilometers squared. Write down the matrix that represents an enlargement, scale factor 3, center 0, 0. Here is the matrix that represents an enlargement with center 0, 0. The number for the scale factor, which is 3, is represented in the major diagonal of the matrix. Simplify 5m squared times 2m cubed. When the m terms multiply, their powers add, and so we can rewrite this as 5 times 2 times m raised to the power 2 plus 3. 5 times 2 is 10 and 2 plus 3 is 5. And so the final answer here is 10m raised to the power 5. Simplify x raised to the power 8 all cubed. The powers of x multiply, so we can rewrite this as x raised to the power 8 times 3. 8 times 3 is 24, and so our final answer here is x raised to the power 24. Without using a calculator, work out 2/1/4 divided by 3/7. You must show all your working and give your answer as a mixed number in its simplest form. In the first step, we convert the mixed fraction 2/1/4 into an improper fraction. And so 4 times 2 plus 1 is 9 divided by 4. In the next step, we have 9/4. Then we replace the division with multiplication. And then we bring in the reciprocal of 3/7, which is 7/3. 3 goes into itself once and goes into 9 3 times. So for the numerator, we have 3 times 7 giving us 21. And for the denominator, we have 4 times 1 giving us 4. 21/4 is an improper fraction, and so we need to convert it into a mixed fraction. 4 goes into 21 5 times with a remainder of 1, which we divide by 4. And so we have 5/1/4. Solve the simultaneous equations. You must show all your working. Let's label the equations. We can start by eliminating the variable y. To do this, we multiply equation 1 by 3, which gives us 15x plus 24y equals 12. Let's call this equation 3. Now we multiply equation 2 by 8, which also gives us 4x plus 24y equals 56. Let's call this equation 4. So now we have 24y in equation 3 and equation 4. So we can easily eliminate the variable y by subtracting equation 4 from equation 3. This gives us 15x minus 4x equals 12 minus 56. 15x minus 4x is 11x, and 12 minus 56 is -44. When we divide both sides by 11, we get x equals -4. We can find the value of y by substituting x equals -4 into any of the equations. If we pick equation 1, we have 5 times -4 plus 8y equals 4. When we simplify this equation and make y the subject, we get y equals 3. Shona buys a chair in a sale for $435.60. This is a reduction of 12% on the original price. Calculate the original price of the chair. The sale price we've been given is a 12% reduction on the original price. So we subtract 12% from 100%, which gives us 88%. This means 88% of the original price should be equal to $435.60. When we make the original price the subject, this is what we have. When we type this into the calculator, we get $495. By shading the unwanted regions of the grid, find and label the region R that satisfies the three inequalities. There are three lines on the diagram, which are the boundaries for the three inequalities. So first, we identify the equation of each of the lines. We can start shading the unwanted regions. For y is less than and equal to negative half x plus 6, the wanted region is below the line y equals negative half x plus 6, and so we shade the region above the line. For y is greater than and equal to 3x minus 4, the wanted region is above the line y equals 3x minus 4, and so we shade the region below the line. For x plus y is greater than and equal to 5, the wanted region is above the line x plus y equals 5, and so we shade the region below the line. After shading all the unwanted regions, the final wanted region that satisfies all three inequalities is left unshaded. This is the region we label as R. Find the largest value of x plus y in the region R where x and y are integers. This value is the peak of the region R where x is negative 2 and y is 7, giving us a maximum for x plus y as 5. Write as a single fraction in its simplest form, 2x over x plus 3 plus x plus 3 over x minus 5. We get the LCM by multiplying the denominators. For 2x over x plus 3, since we multiply the denominator by x minus 5 to get the LCM, we also multiply 2x by x minus 5. For x plus 3 over x minus 5, since we multiply the denominator by x plus 3 to get the LCM, we also need to multiply x plus 3 by x plus 3. When we expand 2x times x minus 5, we get 2x squared minus 10. When we expand x plus 3 times x plus 3, we get x squared plus 6x plus 9. 2x squared plus x squared is 3x squared. Minus 10x plus 6x is minus 4x. And so our final answer here is 3x squared minus 4x plus 9 divided by x plus 3 times x minus 5. The table shows the number of people in different age groups at a cinema. Dexter draws a histogram to show this information. The height of the bar he draws for the group y is greater than 15 and less than and equal to 25 is 7 centimeters. Calculate the height of each of the remaining bars. The frequency density gives us the height of intervals on the histogram. For the interval y is greater than 15 and less than and equal to 25, the frequency density is equal to the frequency which has been given as 35 divided by the interval width, which is 25 minus 15. This gives us 3.5. Since the height of the interval drawn on the histogram is 7 centimeters, this means 3.5 times a certain scale factor should be equal to 7. This scale factor is 2. So for the interval y is greater than 25 and less than and equal to 30, its height will be 2 times the frequency density, which is 32 divided by 30 minus 25. This gives us 12.8 centimeters. For the interval y is greater than 30 and less than and equal to 50, its height will be 2 times the frequency density, which is 44 divided by 50 minus 30. This gives us 4.4 centimeters. Then finally, for the interval y is greater than 50 and less than and equal to 80, its height will be 2 times the frequency density, which is 12, divided by 80 minus 50. This gives us 0.8 centimeters. Rearrange this formula to make m the subject. P equals k plus m divided by m. When we multiply both sides by m, this is what we get. We want to make m the subject, so we put all the m terms together to get pm minus m equals k. When we factor out m, we are left with p minus 1. When we divide both sides by p minus 1, we get m equals k over p minus 1. Solve the equation 3x squared minus 2x minus 10 equals 0. Show all your working and give your answers correct to 2 decimal places. To solve this equation, we can use the quadratic formula where a is 3, b is negative 2 and c is negative 10. When we plug in these values into the formula, this is what we have. The numbers under the square root, which is negative 2 squared minus 4 times 3 times negative 10, gives us 124. And for the denominator, 2 times 3 gives us 6. And so for the first possible value of x, we have 2.19 rounded to 2 decimal places. And for the second possible value of x, we have negative 1.52 rounded to 2 decimal places. In the Venn diagram, shade x complement intersection y. In other words, we are asked to shade the region belonging to elements that are in set y and not in set x. This is what the result should look like. The Venn diagram below shows information about the number of gardeners who grow melons, potatoes, and carrots. A gardener is chosen at random from the gardeners who grow melons. Find the probability that this gardener does not grow carrots. The pool from which the gardener is picked is from the set of gardeners who only grow melons. And so, this probability is equal to the number of gardeners who grow melons and do not grow carrots divided by the number of gardeners who grow melons. From the Venn diagram, the number of gardeners who grow melons is 3 plus 6 plus 5 plus 2, and the number of gardeners who grow melons and do not grow carrots is 3 plus 6. This gives us 9 over 16. Find n of m intersection p union c complement. In other words, we are finding the number of gardeners who grow melons and potatoes in addition to the number of gardeners who do not grow carrots. When we sum all the numbers in this region, we get 46. Calculate AB. Matrix A and matrix B are 2 by 2 matrices. And so when we multiply these two matrices, the result should be a 2 by 2 matrix. To get the number in this position, we multiply the elements in row 1 of matrix A with the elements in column 1 of matrix B. This gives us 6. To get the number in this position, we multiply the elements in row 2 of matrix A with the elements in column 1 of matrix B. This gives us 3. For the number in this position, we multiply the elements in row 1 of matrix A with the elements in column 2 of matrix B. This gives us 15. For the elements in this position, we multiply the elements in row 2 of matrix A with the elements in column 2 of matrix B. This gives us 7. And so we have 6, 3, 15, 7. Find the inverse of A. The inverse of matrix A is equal to 1 divided by the determinant of matrix A times this vector. To get this vector, we swap the numbers in the major diagonal of matrix A and negate the numbers in the minor diagonal. To get the determinant of matrix A, we subtract the product of the minor diagonal, which is 7 times 1, from the product of the major diagonal, which is 2 times 3. This gives us -1. So we have 1 divided by -1 times 3 -1, -7, 2. 1 divided by -1 is -1, and so when -1 multiplies all the elements in the matrix, our final answer becomes -3, 1, 7, -2. ABCD is a parallelogram with AB equals Q and AD equals P. ABM is a straight line with AB is to BM equals 1:1. ADN is a straight line with AD is to DN equals 3:2. Write MN in terms of P and Q in its simplest form. MN can be expressed as MA plus AN. Remember that AB is to BM is 1:1, and so if AB is Q, then BM is also Q. So now MA is -Q minus Q, and AN is P plus 2/3P. So how did we get DN as 2/3P? We were told in the question that AD is to DN is 3:2, and we know AD is P. So what would DN be? This is what we are calling X. And so to find X, we cross multiply and make X the subject. This gives us X equals 2/3P. -Q minus Q is -2Q, and P plus 2/3P is 5/3P. And so our final answer here is -2Q plus 5/3P. The straight line NM cuts BC at X. X is the midpoint of MN. BX equals KP. Find the value of K. BX can be expressed as BM plus MX. X is the midpoint of MN, and so MX is half of MN. BM is Q. We found MN in the previous question as -2Q plus 5/3P. When we expand the brackets and group like terms, we have BX equals 5/6P. Therefore, K is 5/6. ABCDEFGH is a cuboid. AB is 18 centimeters, BC is 7 centimeters, and CG is 12 centimeters. Calculate the angle that the diagonal AG makes with the base ABCD. On the diagram, we've labeled the angle between AG and the base as alpha. We can find this angle using SOHCAHTOA. This gives us tan alpha equals the opposite, which is GC, divided by the adjacent, which is AC. We already know GC is 12 centimeters. So now let's find AC. AC is the hypotenuse of the right-angled triangle ABC. And so we can find its length using the Pythagoras theorem. This gives us AC squared equals AB squared plus BC squared. AB is 18 centimeters and BC is 7 centimeters. When we substitute these values into the equation and make AC the subject, this is what we get. 18 squared plus 7 squared is 373, and so AC is square root of 373 centimeters. Now that we know the length of AC, when we make alpha the subject of the equation and plug in the lengths of GC and AC, this is what we have. When we type this into the calculator, we get 31.9 degrees rounded to 1 decimal place. Describe fully the single transformation that maps triangle A onto triangle B. When we look at triangles A and B, we can tell straight away that this is a rotation 90 degrees in the clockwise direction. So now we need to identify the center of rotation. For a 90-degree rotation, the way to determine the center of rotation is this. We draw a line to connect at least 2 corresponding points on both triangles. Then we need to draw the perpendicular bisectors of these lines. The intersection point of the bisectors is the center of rotation. In this case, the center has coordinates 1, 0. And so the full description for the transformation will be rotation 90 degrees clockwise about the center 1, 0. Describe fully the single transformation that maps triangle A onto triangle C. When we look at triangles A and C, we can tell straight away that this is an enlargement by a scale factor of 2 because corresponding lengths of the triangles are in the same ratio, which is 2. This is a negative scale factor because triangle C is not in the same orientation as triangle A. It has been flipped. And so from here, all we need to do is find the center of enlargement. We can do this by connecting at least 2 corresponding points on both triangles. The intersection point of the lines is the center of enlargement. In this case, we get the center as 0, 2. And so the full description for this transformation will be enlargement by a scale factor of -2 about the center 0, 2. Thank you for watching. I hope you found this video useful. See you in the next video. Bye guys.